My name is Brianne Leeming, and I am the founder and CEO of Unruly Studios. Today I'll tell you how we integrate active play with STEM education for the first time ever. So we actually get kids up, moving around, and learning to code. STEM skills are very important for kids to learn today at a young age. As tech seeps into every career, no matter what a kid does in their future, they're going to need the basic skills of problem solving with technology. And the best way to learn this is by teaching kids coding at a young age. But I also want to talk about something really important, which is playing. And I mean this kind of playing. This is what play looks like. Parents want their kids playing this way. Kids like to play this way. And doctors recommend that kids play this way too. The problem with current STEM products on the market, even the most engaging experiences for kids, still have them looking like this. They're sitting for long periods of time, often playing alone and getting a lot of screen time while they're at it. At Unruly Studios, we do STEM education differently. This is what it looks like to play with our products. So for the first time ever, we offer active STEM play experiences for kids 6 to 12. So active because we have them actively learning, they're building products for the real world, they're building solutions for the real world. STEM because it's beginner problem solving for kids, but also beginner coding. And play, because it's both physically active play, but also social play. They're playing with each other, multiplayer games. Our first product is Unruly Splats, which is a set of electronic floor buttons that light up, make sound, and sense when they're stepped on. So kids run around the room and play active games on the buttons, things like hopscotch, whack-a-mole, relay races or obstacle courses or dance routines. So you can imagine we have over 50 different categories of games that kids have invented for our product. And the coolest thing is they can be programmed wirelessly. So they are Bluetooth capable and they're connected to an app interface which plays using the Scratch programming language from MIT. So Scratch already has about 20 million kids using it and coding, and they're doing this drag and drop coding language, which I'll take you through in our demo. So they're able to program any games they want into the system. We are selling the Splats in packs of 2 for $149. We're patent pending with the Splat product. I've put together a team of experts from the toy industry, from technology, business, and education. We have backgrounds from companies like Mattel, Hasbro, iRobot, and also places like the MIT Media Lab who created Scratch. And the coolest part is we're not just building this first product. We have many products to come that we'll be building into a platform of the Unruly world, letting kids make the rules for real-world play and active experiences. So our coding platform that we're building now is going to connect with all the future products. So the same software connects with future physical products that we'll put into the system that kids can program to create active play experiences around the room, like full obstacle courses, building escape rooms of their own at home, Indiana Jones, you can picture that type of play. And they can share all the games they've created online with our online community. We've tested our products. We've built 15 different versions of the prototype and tested it with over 3,000 kids, parents, and educators, and they love the Splats. We've won awards for this product. We work with partners like the Boston Children's Museum. We just finished up a Kickstarter campaign collecting pre-orders 1 year in advance of delivery and raised $33,000 and have about 1,000 Splats that we'll be delivering for next October. So we're going right into manufacturing now. So thank you so much. Our call to action today, and I'll do the demo afterwards, is that we are looking for software developers with app experience for kids to take us from our web app into our final iOS and Android applications through the tablet. And so we're looking to fill a CTO role. So if you know anyone, have friends, please let me know. Oops. And so I'll show you first. This is our newest version here, and then I will do a little demo. So this is just the current version of the Splats. Happy to have you come up and play with it. And they work like buttons. Each individual light is programmable, so you can even do games where you're shooting lights across the Splat. They can be put 25 feet apart with the Bluetooth capability. And then, can you see it up there? Oh yeah, okay. So this is our app right here, connected up to the splats on the ground. And so this is a game of whack-a-mole that a kid created. And if you can see, is it big enough for you all to see, or do I need to zoom in a little bit? I can zoom in a little. Yeah, there we go. So just so you can see how simple it is for kids to drag and drop all the logic that they want in and out. This is telling the splats to be lime green for a random amount of time, and then flash fuchsia, fuchsia being the mole that they have to whack. And then we have sounds that go along with it as well. So here's the game here. So they're on random timers, which makes it really game-like. Oops. Sorry, it's not working. Of course, when I do a live demo, it doesn't work. Hang on a second. Oh, you know what it is? I think my sound on my computer wasn't on, that's all. That's an easy fix. Oh, nope, that wasn't it. Sorry about that. But normally they would be making sounds to give you the feedback of being pressed and being stepped on. So I'll have to fix that up and show you afterwards. But we're currently manufacturing our first run, and we'll be on the market for next Christmas. So I'd love to take some questions. Yeah.
How many hours of operation can one slot undergo?
So we're working on 3 AAA batteries for each slot. And so we don't have the exact number but it should last about a month of playtime, because they're only draining battery when they're lit.
How about mechanically? When you press them?
Oh, yeah. Yeah, so we have spent a lot of time finding the right sensors to make these as durable as possible so that they can withstand. So we've actually ended up with a relatively simple sensor from the toy industry, which can take millions and millions of activations and be totally fine. Yeah, it's a good question. Yeah?
What's the process of the kids learning how to use this and how to code? Is that part of the web app?
Yes, so the web app is we're designing a full tutorial experience, bringing them through this. So just showing this was kind of an open-ended play. It'll come preloaded with 5 games that kids can take right out of the box and play with. And then they can modify those games, but they can also go through our challenges and tutorials to just learn very simply. So we're aiming to be a kid's first coding experience. That's why we designed it for ages 6 to 12, for a really young age group, very approachable. So the app will really take them through. If their parent, if a teacher who's teaching a class with these has never programmed before, that's fine. We're basically building this on-ramp so that it's very, very simple. Yeah.
If you're still open to avenues of inspiration and scratch I don't know if they're still doing it, but Lego, they used to do a brain brick kind of thing.
Mm-hmm. Mindstorms. Yeah.
Great. That really drew in.
Oh, yeah. There's a lot of different, so eventually we can also be, connecting into a text programming language and having kids at a more advanced level take into Python and start learning in that way. So, and it's funny, but younger and younger kids are able to learn those languages now, so. Yeah.
What's the age group? It says 6 to 12?
6 to 12.
Products that you want for early teens?
Yeah. So interestingly, we've had a lot of interest from teachers in the curriculum level of having high schoolers take these and program them for a younger classroom. So to be able to actually program for real users, for them to play in gym class the next week, a high school class could be using this as part of a computer science curriculum to program for a younger grade level. So, and they actually enjoy playing with them a lot too. When we work with older kids, they always just come up with different games. So there's a lot of different applications for older kids, even college. Yeah.
How do the stress communicate with the computer? Just wire or Bluetooth?
Bluetooth, yeah. So this version is the last wired version. This version we're adding Bluetooth to currently, and we'll have that by January. So yeah, we're just aiming that direction. I should really be talking to that API company who was here earlier about that. Yeah.
Are you using distribution?
So we have B2C and B2B strategies. The first thing that we've done is launch the crowdfunding campaign to meet our early adopters, and that was all B2C. But we had a lot of teachers find us through that, actually. So there's a lot of school interest, starting with the teachers and eventually going through B2B, through after-school programs, museums, libraries, and schools. So B2C is through kind of the direct online places, Amazon, but a lot of really targeted places where STEM toys are already being sold. Yeah.
What kind of evidence is there that a programming experience of this sort translates to later programming ability?
Right, yeah. So we base a lot of that on the Scratch community, so Scratch currently has about 20 million kids using and has been studied extensively. And so a lot of the early stuff kids are learning with this is that they're just learning the basic logic. So it's how a computer works, they're learning how to fix bugs, problem solve, reduplicate code, do simple coding experiences like for loops, forever loop, like things like that, create their own blocks. So being able to make shortcuts for themselves. So teaching them all those skills that they can eventually take to a future programming language. So all of that, including the way that they interact with our community, is very applicable to future coding languages that they'll learn. So a lot of it's kind of the basic coding, computational thinking.
And actually translated the skills. So somebody who starts in 15, for example, not using this, maybe they start with Python, do they do any better or worse than somebody who started?
Yeah, that's a good question. It'd be really interesting to study it from that. I haven't seen the exact studies yet, but there are a lot of languages, and what we'll offer as well is that you can toggle between this and a text language. So it is a really good ramp to be able to see exactly what this does, but then immediately translate it into a text language and see what that would look like in Python or what it would look like in JavaScript. So it'll be.
Thank you.
Thank you.